Hello everyone, I am Birsurang Deimari. First of all, I would like to welcome you all to the online learning platform of Engineers Educare Coaching Center. So, this is a demo video for that platform that I speak about just before, and I will be teaching you today about kinematics of fluid flow, which is inside the fluid mechanics course in your JEE exams. Now, this topic particularly is very important for all the exams that will be appearing for JEE or for your AE conducted by PPSC or any other relevant government jobs. Now, to understand this topic, kinematics of fluid flow, first you must be familiar with the term. It is called the kinematics. Now let me explain to you what this term kinematics means, and the definition will be provided at your screen. Please pause the video and you can write it if you want. Now let us say that I have a fluid particle which is over here. Now let's say this is our channel or pipe, whatever you want to think of. Now let's say this fluid particle is moving from position A to our position B. So let's say this is our position B. Now the fluid is moving from point A to the point B. Now we can think why this fluid is moving from point A to point B. Maybe there is some forces that is pushing the fluid from point A to point B. Now if we consider the force, or if we talk about the force and why it is moving, then it is not the kinematics. We will be discussing about that in our dynamics of fluid flow. Now in the kinematics, this fluid is moving from point A to point B. Then we will be studying only about the flow properties. Why it is moving, how it is moving. We are not going to discuss about that in this particular kinematics of fluid flow. So let's say this fluid is moving with some velocity v. So v, this we are going to discuss. This fluid particle is having some pressure P. So this is our kinematic property. So in the dynamics, we will be studying why it is moving and in which direction it is moving and all those things. But in kinematics, we will be studying about this particular fluid flow. Okay. So the definition is already provided. You can write about it. So I am dictating the definition. It is kinematics is defined as the branch of science which deals with the motion of particle without considering the force causing the motion. So just in kinematics, very important point, remember, it is without considering the force. This is a very important point in the kinematics, without considering the force. Okay. So that being said, now we have understood what the kinematics means. Now inside that, we are going to now discuss about the types of fluid flow that will be occurring in a fluid. Okay. So I am going to rub this. If you want to make it, you can pause the video and write it. So earlier we have discussed the term kinematics of flow. Now we are going to discuss about the various types of flow that will be occurring in a fluid. So if I have listed out the different types of flows that occurs. Number 1, it is steady and unsteady flow. Number 2, uniform and non-uniform flow. Number 3, laminar and turbulent flow. Number 4, compressible and incompressible flow. Number 5, rotational and irrotational flow. Now, this topic is very important for either your JEE exam or your AE exams, either in objective or in the subjectives. Please note down these types of the flows. We are going to discuss them one by one in a short while. So you can pause the video and write it down. So now I am going to discuss about the first one, that is the steady and the unsteady flow. Now let's say that I have one particle of fluid. Let's say this is our channel. This is the first particle at point A, and let's say I am having one particle. It's moving from point A and it's moving through point B. Now this thing is illustrated in our animation also. Now in the animation you can see that at point A the velocity is 10 meter per second. At point B the velocity is still 10 meter per second. When it is moving at point C, it is still 10 meter per second. That means what? When it is passing from A to B, then B to C, what is changing? The time is changing. Okay? Now, the time is changing, but the velocity is not changing. What is velocity? It is the fluid property. Now, when it is moving, the pressure may also not change, or the viscosity or the density, those things may not change. Now, when I'm writing here, point A, let's say the velocity is 10 meter per second. At point B, the velocity is still 10 meter per second. Let's say I have a point C. Here also the velocity is suppose 10 meter per second. Now, when I'm saying here the velocity at A is 10 meter per second, my velocity at B still 10 meter per second, velocity at C, it is still 10 meter per second. Now, if you see the change from point A to point B, what is the change? It is 10 minus 10, it is the 0, there is no change I mean. When it is moving from point B to point C, what is the change again? 10 minus 10, 0. That means there is no change. So this kind of the flow, where the property of the fluid does not change with respect to time, it is called as the steady flow. So remember, the steady flow we are going to see with respect to the time. So mathematically, if I write this equation, let's say delta V upon delta T, what is it representing? The change in the velocity with respect to the time. How much it is changing? There is no change, it is 0. Similarly, if I am writing about the pressure, change in the pressure with respect to the time, how much? It is still 0. Change in the density with respect to time, how much? It is still 0. So these things, it is the mathematical expression for the steady flow. So remember the mathematical expression, delta V upon delta T is 0, delta P upon delta T is 0, delta rho upon delta T is 0. That means what? The change in the fluid property with respect to time, it is 0. So the proper definition, it is shown in the screen. I am going to dictate it. You will pause the video and write the definition down. Okay. It says, steady flow is defined as the type of flow in which the fluid characteristics like velocity, pressure, density, etc. do not change with respect to time. So, what is the meaning of etc.? There may be some other properties other than velocity, pressure and density. So, if the fluid property is not changing with respect to time, what it is? It is the steady flow. Now, this is all about your steady flow. When you are coming to the unsteady flow, it is simply the opposite of the steady flow. So in the steady flow, what was happening? The fluid property was remaining same. So let's say when it is at point A, it is 10 meter per second. When it is moving at point B, let's say it is not 10, it is 12. When it is moving at point C, let's say it is 14 meter per second. That means what? The time is changing, property is also changing. That means what? It is called as an unsteady flow. So mathematically, if I write change in the velocity with respect to time, is it still 0? No, because it is 12, it is 10, that means there is some change. So not equal to 0. Here also not equal to 0, not equal to 0. So these are the mathematical expression for the unsteady flow. So the definition of the unsteady flow, it is shown in the diagram, you write it down. It is simply the opposite of the steady. Now, from your exam perspective, if you are said to write down the difference between steady and unsteady, or then what you are going to do? You are going to write the definition. Also, don't forget to mention the mathematical expression. And in some objective exams, what they do, they will give you the mathematical expression and you are told to identify what kind of flow it is. Okay? So remember, I hope you have understood the concept of steady and the unsteady. Now we will be moving to uniform and non-uniform. So I am going to erase this. You pause the video and write it down if we have not written it. Okay? Okay. So now we have discussed steady and unsteady flow. Now we will be discussing about the second one, uniform flow and the non-uniform flow. Now in the exam, most of the students, they get confused between this steady and this uniform. So I am going to explain to you, try to grab the concept between the steady and the uniform flow. Okay, there is a vast difference. So let's say we have a channel again. I am taking one cross section. This is suppose A. I am taking one more cross section. Let's say this is our cross section B. Now let's say at cross section A, I am having some fluid particles. Now these fluid particles are moving in this direction. Let's say the velocity here is, for example, 10 meter per second. Here also, for example, 10 meter per second. Here also 10 meter per second. Now when it is moving to other point B, the fluid is still moving in the forward direction. And let's say in this particular second position, the velocity is suppose 14 meter per second, 14 meter per second. Here also suppose 14 meter per second. Now you observe what is happening here. This is the width of the channel or width of the pipe. So to explain this, I am giving you one diagram what this is actually representing. It is actually representing the width of the river or width of the channel. Okay. Now when I am taking one cross section, the property velocity 10, here also 10, here also 10. That means what? The fluid property is same where along the width of the channel. In the steady, the fluid property was same where when it was moving through time. Okay. So here change in the velocity with respect to space. I am talking about the space here, not more the time. So this is equal to 0. This is the mathematical expression for your uniform flow. The proper definition I am showing in the screen and I am going to dictate it. You please pause the video and write it down. Okay. The uniform flow is defined as the type of flow in which the velocity at any given time does not change with respect to space. Okay. It is with respect to space. Remember, what is the meaning of space? That is length of direction of the flow. Okay. So length along the direction of the flow. So remember, steady is measured with respect to time. Uniform and non-uniform, they are measured with respect to the space. So this is the mathematical expression for the uniform. Now when I am talking about non-uniform, it is simply the opposite of the uniform. So let's say along the width, at one point it is 10 meter per second, at some other point suppose 12, at other point suppose it is 14. So along the width, the property is change, it is not same. So delta velocity with respect to space, is it 0? It is not 0 because there is a change. So this is not 0. So this is the mathematical expression for your non-uniform flow. This is the mathematical expression for the uniform flow. Okay. So remember, steady, unsteady with respect to time, uniform, non-uniform with respect to the space. Okay. So this is also illustrated in your animation. So please note it down. I am going to erase the board. So we have discussed these first two. So there is a laminar and turbulent, there is compressible, incompressible, there is rotational and irrotational flows. Now since this is a demo class, I am here only to explain these two. The remaining I am going to explain you when we go in detail about this course. Okay. So I will stop my demonstration of this class. So what was our aim here? Our aim was to just to interact with you and show the methodology that we are going to adopt when we will be taking our main class. Okay, so I am going to stop it here. Thank you.